All right, welcome to another video tutorial on the Snakes and Ladders game programming project. So we're going to continue from where we stopped last time, and just a quick review of where we are. I'm just going to reload this page. And last time we have been able to include the codes that allow the character that the user has chosen to be placed on the snake board. So just a quick review of that part of the code. What will happen is, of course, when you run it, you put your name here, you hit enter, and then of course you have the home screen that shows the snakes and ladders. You have a start button, and you get to choose which one of the characters you want, of course, after you've chosen the start button. Let me just rerun that again. Oh, there it was. I think it was a bit slow on loading, so let's do the rerun. Okay, so we have a part of the game running down here. I'm just gonna minimize that and then hit enter again. So we have the start button, click on start. Now there we have it. Which character would you like to choose? So if I choose character B, then it goes to the start here section, and that's the character that will be moving across the snake board depending on what position the computer will choose, of course. And then, of course, depending on the rule as well, if the character lands on the snake head, it automatically goes down to the snake tail. If it goes on the bottom of the ladder, it automatically goes up. And that's the whole point of the game, is to get to the home section, which is where we have a celebratory screen that shows up after that, celebrating and telling the user congratulations, on completing the game. So to continue working on that, we are going to put our date modified. So as of making this video, this is the 17th of October, 2023. And then we're going to go back to the code where we ask the user, would you like to roll the dice? And they say yes. So basically we're putting in the codes that gets the animated dice rolling animation to work. So we have like all the frames, the first, the second, the third, and fourth, and fifth. Combining all that together would get that animated dice to roll. So I'm going to continue with an elif statement. So here's going to be elif x is equal to 2. Then we are going to use the roll again. So I'm going to use the roll.pinup, the same turtle object that we created called roll. And I'm going to say roll.goto. So kind of the same parts of the code here, going to the same 30, negative 30. That's where the dice is going to be placed on in the center of the screen. And then, of course, we have roll.pen down. And then finally, we have the screen.add shape. And basically, we are adding frame number 2. So frame2.gif. And then we are going to do roll.shape frame2.gif. So pretty much the same blocks of code. The only thing that really does change is just the name of the frame. So we're going to do this for the remaining 3 frames because there's a total of 5. So we need to combine all together. So what I'm going to do is just copy this block and then just come down here and paste. And of course, make sure you space this in. So indent it, use your tab key on your keyboard. And this is going to be for elif x is equals to 3 now, so it's a totally different x variable. I'm not sure why I have these orange lines over here. Let me just try doing this part first, so I don't want to have those orange lines showing. And then I'm just going to copy this block here and then paste it down there. All right. So, and then, oops, why is that happening? Okay, there it is. So then I will just change this to frame 3. Now I'm going to do the same thing here again. So elif x equal 4. So just copy paste the block again. You're not changing the position of where you're going to be placing the dice. It has to be in the same position. You have to use the same pen because you're basically just creating that animated effect. So here you're going to go with the whole roll.pinup, and then this is going to be frame 4. So just copy this block and then just change only the frame name to frame 4 and frame 4. That's pretty much it. And the last one is going to be for if x equal for the 5th frame. And obviously this is going to be now the same again. So roll.pinup, and this is going to be for frame 5. Now, once all the frames are included, you do have to increase x by 1. So x equal x plus 1. Okay, and then when it's on the 5th, when it's finished rolling, this is where we want to be able to call back the snake board function so that it gets the token gets the token placed. So basically, once the dice finishes rolling, we're going to be calling the snake board function so that the token, that means the image icon that the player has chosen will get to be placed back on the snake board. So at this point, we are going to, let me just confirm something. There it is. Okay, so we're going to be going after this. We're going to give like a time gap, time.sleep for about 0.1 milliseconds. And then we're going to say if x is equal to 5. So if it gets to the 5th frame, which is when the dice finish completing its animation or its process of being animated, once it gets to that place, we're setting player num equal to 1. Okay, and then we're going to say time.sleep again, wait for another 0.1 milliseconds, and then we're going to clear the screen. And the reason we're waiting for such a short time is because we want to create a very natural effect of transitioning. Basically, the dice, we've asked the user, would you like to roll the dice? The dice has finished rolling, and now the icon is getting to, the token is going to be moved on the snake board. So that whole transition process of showing the token on the snake board, and after you've asked the user if you want to roll the dice and you finish the animation of the rolling of the dice, then we want that process to be smooth. So here we go, screen not clear, and then we're going to call the not token, but the name of the function is called the snake board, which is the one that gets to move the token character on the snake board, the function that we've already made here. Now that is that process. The next thing we want to do after this is we're going to go to the next process. The most important one is where we get to make the computer start choosing the position. So the position obviously meaning, so I'm going to hit enter from here. The computer will choose from positions 1 to 12. And that would be, excluding 1. The reason I'm excluding 1 is because there's 2 dice, and that's the dice. And we are basically adding the numbers that appear on each face or each die face. And so we can't use 1 because there's no 0 on each die face. There's only a minimum of 1. So if 1 appears on each die face, then 1 plus 1 is 2. So we can't really use 1. We're going to have to start from 2 to 12. So we're going to be creating a list of random numbers, and in this list we're going to say equal to open square brackets. We're going to go with 2, we're going to go with 3, and then we're going to go with 4, and then kind of like 5, all the way to 12. So we're going to go with 5, and then so these are all the face numbers that will appear on the die. We're going to go with 6, then we're going to go with 7, and then of course we'll go with 8. Then we have a 9, and then of course a 10, and then we have an 11, and of course we have a 12, right? So these are all the faces that appear. So it's true basically all the way to 12. Now the computer will randomly pick any number from this list, and that's how we get to move the token across the snake board. So what we're going to do is we're going to be creating a variable. I'm going to call this computer choice, or you can call it com choice. And so com choice will be equal to random.choice. And this is how we get the computer to choose from this random numbers list. Okay? And then the next thing to do is we're going to be saying if the computer randomly chooses, if com choice is equal to 2. So the computer chooses 2. Then in that case, we are going to add 2 to the position. And I think this is where we actually had to have position. I don't think we've globaled position, which we definitely need to do, because position is very important. We need to global it. So I think what we can do is just go back up to your code. We never created position, and position is important because that's how we move the token across the snake board. Initially, the token is placed on start here, as you can see, this little token. Now we're talking about this one. And so it's on a 0 position. Now, if the computer chose 5 as its position, well, 5 from this number list, then that means that the token would move 5 places forward. So 1, 2, 3, 4, 5. And then, of course, if from here, the token's new position will be here on 5. And if the computer chose something like 10, for example, it means that the token's going to move 10 positions from here because this is its new updated position. So it's going to move from here 10 more positions, which means arriving at 15 and so on. So what we need to do, position is a very important variable. We first need to declare it at the top. So on lines 22, we are going to set position equals 0, and then we're going to come after global player num, we are going to global position as well, so that we can be able to use this variable inside of this function. Now let's go back. Now that we've done that, we're now in the main game phase, and this is where we start to do the whole condition. So if computer chooses 2, then position is equals to position plus 2. So it's going to the token is going to move 2 places forward. I'm just going to zoom this in for a better view. And then we continue on with elif. What about if the computer chose position 3? So what would happen is wherever the token is positioned at, it will move 3 places forward. So again, you notice that we're using the same variable so that we can update the position every time. So it's going to be position plus 3. And then you're kind of going to continue this all the way to position 12. So elif, again, computer choice. So if com choice is equal to the 4th position, then of course this means that position will be equal to position plus 4. And then this has to come again for the 5th one. So elif again. So elif com choice is equal to the 5th position, then we are going to get position equal position plus 5. And then of course we're going to go to the next one. Elif computer chooses com choice is equal to the 6th position, then we're going to do position is equal to position plus 6. And then we're going to do the same thing for the 7th one. So you can pretty much just copy this block, to be honest, and just paste it down here. And you just have to change this to, so of course paste this in and then just change this to, the only thing is I realize when you're doing that, it's for some reason it gives you an orange line. So that's what I don't like. So I'm just going to type it out. So I'm giving my 7th position. I'm going to go with my 8th one. So elif com choice, if that's equal to the 8th position, then what really happens after that, of course, is position is equals to position plus 8. So position equal position plus 8. And then, of course, we go to the next one, which is elif com choice equals to the 9th position. Then, obviously, this is going to be position is equal to position plus 9. And this really just goes on and on and on all the way to the 12th one. So elif position equals 10. So this is a 10th position, then position. Oh, this is actually supposed to be com choice, so be careful with that. That's what happens when you're trying to go too fast. So it's elif com choice, and so here it's going to be position equal position plus 10. And then here is going to be elif comp choice equal 11th position, then position is equal to position plus 11, and then finally elif comp choice is equal to the 12th position, obviously, and so that's going to just be position equal position plus 12. Now, one thing to do is just do a little inventory check. Make sure that you've put all for comp choice. Make sure you haven't made a mistake here. So this is all comp choice, comp choice, comp choice, comp choice, and make sure you spelled position correctly, of course. So that's a very good way to kind of just check what you've done, and so there's no mistake. And so once it's the 12th position, that's pretty much the end of adding to the position variable. Now we have to kind of now specify when the user is winning, of course. And also not that, but we also have to place the token. So yes, it's true that if the computer, let me just zoom out. If the computer indeed is picking a position, so if this is at 0 and it's 12, it's going to go all the way here. But then how do we place that icon here? We have to know the boundary of this area in terms of the coordinates for X and Y, so we can place the icon if it's on the 12th position, or if it's on the 30th position, or if it's on home, which is where it's supposed to win. So we're going to be doing something now like that, where we get to place the token icon in the right section on the snake board based on the position that the computer is choosing. So what we're going to do now is we're going to come down here and we're going to say if, okay? So I'm just definitely checking through just to see if we have anything that we were supposed to indicate that we haven't indicated. And so no, everything seems to be okay. So now we're just going to start with if position. So I'm just going to put like a comment here. So now what we're doing is we're checking, or not checking, sorry, we're placing the token icon on the right, should I say box, position box, I would say, on the snake board. Okay, on the snake board. So then the next thing to do obviously would now be to start with an if again. So if position, starting with the second one, since it starts with number 2, if position is 2, and so that means if we're talking now about position, we're not talking about computer choice, we're talking about the actual position. So that means, to explain this, is if the token does indeed start at the start here section, so if it starts here at 0 and then the computer happens to choose 2, then it means it's going to move 2 positions, or wherever it is, if it chooses 2, it will move 2 positions forward. And so if, for example, it did start here and the computer did choose 2 positions, then we have to place this icon now here, and we have to be able to place it in the right coordinate area. So these are the box positions that I'm talking about, and that has to happen for any change of the position. So if it does choose position number 2, okay, then it's going to be where we say A is equal, so that's why we globaled A for the X and Y coordinates. We're going to place it on the second box. If it chooses position 10, obviously that means from 2, then it's going to be 12. If it chooses position 11 and so on, it depends on what the position is. So as long as it keeps choosing all those positions, and it keeps going, then we are going to keep, so we're going to do this all the way for a total of about, the maximum is 31 positions. That's like the 31st one. So we're doing it, we're aware that it has to go all the way to the 31st position, which obviously is the one where you see the home. That's the 31st. If it goes anything beyond, if for example, the token is on 26 and the computer does pick like 10, for example, for the new position. So 26 plus 10 is 36. It's going to be more than the home, and that means that the game would be reset and the token icon would come back and start at the beginning again. So the player has not won because it's gone beyond the home. It's supposed to exactly arrive. So that's what makes the game challenging and interesting at the same time. So the A and the B coordinates that we have represent, of course, the X and the Y coordinates. So A is going to be equals to negative 146. Oops, I think I put it twice. So that's exactly where I already know the coordinates of where exactly the second box area is going to be. So I know the boundaries here, but it's just, we don't need to know the whole boundaries. We just need to know an area where we're going to be putting the token on. So a specific area, you don't need to know the entire boundary of each box. And that's what really does save the whole coding process. So here we're going to place it at A is equals to negative 146, obviously. And we're going to say B will be equal. So B representing, you can say the Y coordinate, representing the Y coordinate is negative 210. And then we're just going to call the function, which you guys remember is called the snake board function, that actually is responsible for moving the token on the snake board. Now we move on to the next one. We're going to say elif. So this kind of continues in the same way as we've done with the other one. So elif, not sure why that's not staying in its position. So elif position, if position is equal to 3, so move to the next line. If that's the case, then A is going to be placed at negative 66, and then B is going to be placed at negative 205, and then of course we are going to call the snake board again. So this is kind of going to be happening for all of the other ones. So we're going to do elif again, and elif, we're going to place it here. So elif position is equal to 4. Then again, we're going to come down here. If it's 4, now let's go back and let me explain something to you. Remember the rules of the snake and ladders game is that if the token arrives at the, or goes on top of the snake head, so that's in the 14th box, we're going to make it like that. In the 14th box, we then know that the token is on top of the snake head. In the 28th box, the token is on top of the snake head. In the 22nd box, the token is on top of the snake head. That's why they put the snake heads on those box areas. If the token is on 4, we know it's at the bottom of the ladder. If it's on 11, it's at the bottom of the ladder. If it's on 7, it's at the bottom of the ladder. So what really happens is now if the token is on 4, it's at the bottom of the ladder, it automatically would go to 12. So we're going to have to move the position automatically to 12, and then we're going to set the X coordinate that will place the token here. So if you see me doing something like that on the condition, you should not be alarmed by that because that's pretty normal. So if it's on the 4th one, this means it's at the bottom of the ladder. So that's already one rule there, which means it has to go top now. So then we have to place position equal 12 now. We have to set the AX coordinate to be negative 57. And then we have to set the B coordinate, which is the Y coordinate, sorry, to be negative 46. And then, of course, we have to call the snakeboard function. So snakeboard function will be called. Okay, so that's going to happen. Now we go to the next thing, which is, of course, if it's at the 5th position. So again, if you get this just for some reason, I don't know what's happening with REPL. It seems like some of the features are making things not work as they used to. So I don't know why it keeps going backwards instead of staying here. So here we're going to do if position is on the 5th is equal to 5, then obviously what happens is, so I'm going to shift this again. So if it's 5, it's going to be the A is set to be at 163, and then of course the B is set to be at negative 216. Oops, I needed to put an equal sign. And then finally, we call the snakeboard function. So now we're going to do if it's at position 6, okay? So if it's at position 6, we're going to continue on again. So elif position, I'm just going to finish writing it and then I'll readjust it. If it's equal to 6, then A is now equal to positive 297, and then B is now going to be equal to negative 207. So I'm just going to shift these two section blocks. Just use your tab key on your keyboard if this is happening. For some reason, it just keeps taking it back. So that's like really what you're going to be doing, and the same thing goes for the next one. If it's at position 7, so elif position equal 7, so same thing kind of happens. A is going to be equal to well, if it's a 7, one thing we do have to remember is that if it's at the 7th position, that means, so let's go back to the snake board again. This means that you are having it way at the bottom of the ladder again, so it goes all the way to the top. So now position will change automatically to 9, so the token moves here. So that's another bottom of the ladder rule. So we're going to just highlight that again. So that would be hashtag bottom of the ladder. Okay. And so that means that position will be set equal to 9. So you now know why I'm saying 9, because obviously at the bottom of the ladder on 7, then it has to go all the way to 9. And then here will be A is equal to 295, and then B is equal to negative 49. And then, of course, we call the snakeboard again. So snakeboard is going to be called. Okay, so snake underscore board. And then we are going to space, well, I'm going to space this in like that. And then we are working on if it is on the 8th position. So elif position equals 8th. So I'm going to just shift this in here. Seems like it's going to go back. Okay, did not go back. If it's on the 8th position, then A, this is going to be normal A, x-axis will be 399, and then B. So I'm just picking the coordinates that are in those box positions where I can place those icons based on their positions. And then here I will call the snakeboard. And this just continues. I'm going to do all the way to 10, and then we're going to run this program and see how everything works. And we will be stopping our tutorial for this part here. So I'm going to say if position is equal to 9, we still have to do all the way to the 31st position, which is where the player actually wins. So here A will be equals to 285, and then B will be equals to negative 44, and then we call the snakeboard function. Now the final condition is if position, it's not the final one, but just for this tutorial video, until I do the next part of the tutorial video to add the remaining 11 positions. So here A is equals to 169, and then of course B is equals to negative 73, and then of course we are going to call the snakeboard function. So this whole section will then move all the way here. Now we can run this program obviously, and just to see if this effects of having the the dice roll So let's just zoom out. I'm going to zoom out a little and then roll the dice and see if it works, because it's supposed to ask us, would you like to roll the dice? So I'm going to run this again. And one thing you can do, there's a new way of running stuff. It does show you your runs. So you can just always, instead of expanding it so you don't get confused, just, remove that. You can also clear the screen and then the previous runs disappear. So that's another way to do stuff. So if you clear it so that your latest run just appears. Okay, so I'm going to put in my name here and it shows me the Snakes and Ladders game. I'll put a start. It tells me what character I want to use. So I'm going to go with character D. And then let's see what happens next. So it's supposed to ask me for, let me see, it doesn't ask us if we would like to roll the dice. I think that's because from the part of, we haven't called this function, so that is true. We haven't called the function yet. We just called the snake board, but then snake board just places the token on the start section. So if you can go back to your code and please call the function. The function is called main game. So let's call the function down here so we can actually get it to run, because that's the reason why we were not asked. So after the snake board, then we call the function. So the snake board is the initial thing. So I'm just going to go and clear my screen and start again. So put the name here and then it will start. Now click on start, choose your character. I'm going to go with C, so little foxy. Now it's asking me, would you like to roll the dice? I'm going to say yes. And you can see that effect of the dice being rolled. And then you can see the token moving up and down. So the reason this is happening is because we're not finished with our code yet. We're supposed to have it so that we can be asked every time once the dice is rolled, we can be asked, would you like to roll the dice, and etc. So this is not happening now because we're not done. So you can see the token did move. So I'm going to run it again. The token did move in the beginning, but obviously because we are not done with the condition and we have an open loop structure here. If you go back to the code, we have a while loop here that is still open, which is the reason why you keep seeing the token just blinking on the snake board. So we have to be finished with this for the functionality of the program to work. So it's pretty normal if you're seeing that blinking effect happening with the token. The most important thing I wanted you to test was to see that your dice is actually being animated. So if I click start and then you choose a character you want, so I'm just going to choose A. Then it says, would you like to roll the dice? The whole thing is you get to see, and you see the movement of, it keeps going back to 9. Yeah, but then we're not done yet. So once we're done, you will be able to see it work properly. And for now, it's just getting, you saw the animation of the dice working, and we are going to be stopping in this video tutorial until we come to the next one, where we will continue with all the remaining 11 more positions that we have to do all the way to the 31st position, and of course design a final screen if the user does win that we want to display to congratulate the user. So we're going to be stopping in this tutorial. We still have to put some background music as well, which I think we did not put in, so we will be putting that in next time. All right, so have a great evening and see you in the next video tutorial.